All right, so now we're moving into section 2.2, which is about population density. This part is going to essentially require you to do some basic math just to be able to calculate a variety of types of densities. And I'm going to try to keep track here. Boop, with a little piece of paper for you. This is really good to figure out the amount of people in a given area. If there's a large concentration of people in a small amount of area, being able to calculate different types of densities is going to essentially allow you to figure out why they're even able to do that. So moving into it, population density. Population density can be computed in several ways. Arithmetic density is the most frequently used density measure. Density was defined in chapter 1 as the number of people occupying an area of land. Arithmetic density, physiological density, and agricultural density are examples of measures of population density that geographers use to describe the distribution of people in comparison to available resources. So, the first one, arithmetic density. This one is very simple because all you do is just take the number arithmetic density, number of people, and divide it by the total land area. So pretty simple. Bam. Basic division. Number of people or objects divided by the land area. In population geography, arithmetic density refers to the number of people divided by the total land area. To compute the arithmetic density, divide the population by the land area. Simple. Figure 2.23 shows several examples. Arithmetic density enables geographers to compare the number of people living on a given piece of land in different regions of the world. Thus, arithmetic density answers the where question, so where people are located. However, to explain why people are not uniformly distributed across Earth's surface, other density features or measures are more useful, and that would be physiological density and agricultural density. Moving forward, yes, physiological density. Looking at the number of people per area of a certain type of land in a region provides a more meaningful population measure than arithmetic density. Land suited for agriculture is called arable land. In a region, the number of people supported by a unit area of arable land is called the physiological density. So that one, physiological density, requires you to know a couple of features. Number one, still need to know the number of people, but instead of just regular total land area, you do arable land. Arable land is, as you can see, land suited for agriculture. Next. Oh. Comparing physiological and arithmetic densities helps geographers understand the capacity of the land to yield enough food for the needs of the people. In Egypt, for example, the large difference between the physiological density and arithmetic density is shown in figure 2.23, indicates that most of the country's land is unsuitable for intensive agriculture. In fact, all but 5% of Egyptians live in the Nile River Valley and Delta because it is the only area in the country that receives enough moisture by irrigation from the river to allow intensive cultivation of crops. Okay, next up, agricultural density. Me just jotting down some notes. Okay. And there's a lot of like underlying things that we're going to essentially go into this week when it comes to things that impact population. Because the big one here is technology. Like once we understand agricultural density, you might be seeing that a country doesn't have a lot of farmers. Okay, well, why is that? Well, technology requires that we don't need as many farmers to support a population. So let's get into it anyways. Two countries can have similar physiological densities, but produce significantly different amounts of food because of different economic conditions. Agricultural density is the number of farmers to the amount of arable land. Again, arable land is land suitable for agriculture. Measuring agricultural density helps account for economic differences. Developed countries have lower agricultural densities because technology and finance allow a few people to farm extensive land areas and feed many people. To understand relationships between population and resources in a country, geographers examine a country's physiological and agricultural densities together. For example, the physiological densities of both Egypt and the Netherlands are high, but the Dutch have a much lower agricultural density than the Egyptians. Geographers conclude that both the Dutch and Egyptians put heavy pressure on the land to produce food, but the more efficient Dutch agricultural system requires fewer farmers than does the Egyptian system. So again, technology, where is it located and how is it diffused is a wonderful indicator of where population concentrations are. Because in a more developed country, for example, like the Dutch or the United States, we have a lot of, well, I guess the Netherlands is probably a better example for agricultural density simply because their farming techniques, because they are a more developed country, they are able to produce more with less. Whereas an Egyptian agricultural density might not be as great simply because they don't maybe have the access to technology. So a lot of factors go into population density here. The diffusion of technology, where a country's at in terms of development, internet access, techniques, weather, a lot of factors and variables here. So that was section 2.2. We're moving right along here. Next up, we will have section 2.3, which talks more specifically about population growth. And this is where, again, as we get into like learning about China, there are a lot of issues that go with population growth. So with that being said, that'll end up 2.2. That was population density. See ya.